So everyone can solve this problem. You would easily find that as the square root of 12 and simplify it to 2 square root of 3. Correct? Well, basically that's all we're doing today. So if you would look at our, we're going to start with multiplication. It doesn't make any difference what the root is. As long as the roots are the same, I can multiply the pieces inside. Alright, so this is basically the only rule, and to be honest, that should be the only thing you need to write down. So let's look at this first example. Well, you could easily do this one, right? Square root of 3 times the square root of 12 would be the square root of 36. And then you simplify, in this case we get 6. So here, if I have a cube root times a cube root, and again, they have to be the same root to be able to multiply them, you would get the cube root of negative 27, which is on your list of perfect cubes, negative 3.
Oh, yeah.
Okay? So, your first part of the homework, square root, cube root, any root times an any root, and they have to be the same root, you just multiply the radicands. Then you take your number from there, simplify it, whichever is appropriate. Alright? So, I want you to write this down. The examples themselves, I'll leave up. So, are we done? No. Now done? Again, all you need is this top guy. Again, these two are just example, and you'll do examples in your homework. Well, the next thing we need to do is we need to be able to simplify numbers with variables. Okay? Well, since this is a square root, what's a perfect square that could go into 72?
16.
No.
9.
9 does, 4 does, also 36 does.
36, yeah.
Okay? So if I have 36, so this will end up being the square root of 36 times the square root of 2. So we know we're going to have 6 square roots of 2. Alright, now let's look at the variables. We have x to the third. Well, you would take this power and divide it into here. Well, it doesn't go even, so we have to look for a different way of doing it. So if I change x to the third to x squared times x to the first, I'd add the powers and I get 3, correct? So I'm going to take the square root of each piece. What's the square root of x squared? X, but it will need absolute values. And then what's the square root of x? So when you have this type of problem, you handle the numbers just like normal. We had 36 and 2, 6 squares of 2. Then the x cubed, we broke it into squared and 1, because this one will work, this one will not. The one out front will need absolute values because it started even and went to an odd power, so it needs absolute values, and the other guy is left over. Now, the only other one I want you to show right here is I want to simplify x to the 19th. When you do these, you can't take the 2, the power, the root, and divided it to 19, doesn't come out even. But what I can do is change this to x to the 18th times the square root of x. Because 18 plus 1 would make 19. In fact, when you do these square roots all the time, this second one's always going to be to the first. Now, what's the square root of x to the 18th?
9x.
X to the 9th. Do I need absolute values?
Yes.
Now, I think you'll want to write this example as part of your notes. Okay? So write this example, because this will be something that you're going to get stuck on. Good morning. Later on, Mr. Jones, I would like either yours or Deb's email, because I need some data.
Deb.Jones6477 @gmail.com.
6477.
But I have the computer here, so.
Huh? Are you guys done yet? All right, the second half of our lesson deals with dividing with rational expression, and we're going to rationalize, and that's a big deal, which we've done before. A couple of rules that you're going to need, you eventually will write all this down. No radical can be in the denominator. No matter of square root, cube root, whatever, can't be in the denominator. No fractions in the radicand. So this is technically not legal. You need to write it in this form. And then the radical must be simplified. Okay? So, if you look at this example, this one, the roots have to be the same. The roots aren't the same, you can't deal with it. Well, there's other ways, but you can't deal with it. The easiest way to do it is to go back and now write it as a single root. Because 32 divided by a -4 is?
Negative.
Which is
2.
-2. Because -2 times a -2 times a -2 is -8. All right, so if they give you this form, and if you look at those numbers and you know that they can be reduced, that would be the way you go. Simplifying the way you go. Now this one, I need to rationalize, which means I need to get rid of the radical in the denominator. So, I need to make that denominator a perfect square. So what would be a perfect square that 7 would go into? Maybe like 49. And to get that, you would multiply by the square root of 7. Now, I do it both in the numerator and denominator because this fraction is really 1. So, when I multiply straight across now, I have 2 square roots of 7 over the square root of 49, and we know what the square root of 49 is, correct? And there's my answer. All right, I want you to write this much down, and to be honest, Dylan, you can turn off the video.
This is the bottom one with the bottom.